something changed. On October 29th, 2025, as the interstellar visitor known as 3I Atlas reached its closest point to our Sun, it did something unexpected, something that has left astronomers scrambling for explanations. And what they're discovering now is making some scientists ask questions they never thought they'd have to ask. This isn't about another comet passing through our solar system. This is about an object that traveled for billions of years through the darkness between stars. An object that shouldn't behave the way it's behaving. And the more data we collect, the stranger it gets. If you're ready to dive into one of the most puzzling cosmic mysteries of 2025, hit that like button. Because what I'm about to show you will challenge everything you thought you knew about interstellar visitors. Let me tell you what's happening right now. Because what unfolded in the last few days has changed everything we thought we understood about this visitor. As 3I Atlas approached perihelion, its closest encounter with our Sun, something extraordinary occurred. The comet's brightness didn't just increase gradually as expected, it exploded. The brightness surged at twice the rate it had been increasing before, twice as fast. Astronomers Chi-Sheng Lin from Lulin Observatory and Carl Battams from the U.S. Naval Research Laboratory documented this phenomenon in real time, and they had no immediate explanation for what they were witnessing. Think about that for a moment. This object has been traveling through interstellar space for what could be billions of years. It has passed through environments we can barely imagine, and now, as it gets close to our Sun, it suddenly becomes dramatically more active than any model predicted. Why? The spectrum analysis revealed something fascinating. The comet's light became bluer than the Sun's own spectrum. This blue shift indicates the presence of carbon molecules, specifically C2 and imidazine compounds. These are signatures of active ice sublimation. But here's what makes this unsettling. Radio observations detected that in just 2 weeks before perihelion, 3I Atlas was losing approximately 5.7 times 10 to the 28th power water molecules per second. That's 40 times more than it was losing just 1 month earlier. 40 times more water pouring out into space. Like, as one scientist described it, a fire hose on full blast. Now, you might think this is normal comet behavior. Comets heat up near the Sun. Ice turns to gas. They get brighter. Standard physics. Except 3I Atlas isn't following standard physics. The rate of change is wrong. The timing is wrong. And what we're seeing doesn't match what we know about comets from our own solar system. Before we go further, make sure you're subscribed and notifications are on, because the next few weeks are going to be critical for understanding what we're really looking at here. Space-based telescopes, SOHO, Stereo A, and the new GOES-19 satellite, all equipped with coronagraphs that can observe objects close to the Sun, captured images of 3I Atlas during this critical period. And what they saw was unusual. The comet appeared as a faint but noticeably elongated spot. But here's what's strange. It had no visible dust tail. None. Just this stretched out glow, without the characteristic dust trail that comets normally produce. What does that mean? Some scientists propose that initially, carbon dioxide gas was escaping from the comet, acting as a protective layer that prevented water from sublimating. But then something changed. That protective layer depleted, and when it did, the water ice underneath was suddenly exposed to direct solar radiation. The result? An explosive increase in brightness and activity. But there's another possibility. And this is where things get uncomfortable for some researchers. The composition of 3I Atlas's nucleus might be fundamentally different from anything we've seen before. Remember, this object didn't form in our solar system. It formed around a different star, in a different stellar environment, with different chemical conditions. What if its internal structure is nothing like the comets we're familiar with? The James Webb Space Telescope has been observing 3I Atlas, and what it found adds another layer to this mystery. Webb's near-infrared spectrograph revealed that this comet has been transformed by billions of years of cosmic ray bombardment. According to research led by Romain Maggiolo from the Royal Belgian Institute for Space Aeronomy, these cosmic rays have fundamentally altered the physical and chemical structure of 3I Atlas. Computer simulations suggest that cosmic rays have penetrated approximately 50 to 65 feet deep into the comet's surface, creating what scientists are calling a deep irradiated crust. This crust no longer resembles the pristine material from the comet's home star system. It's been cooked by radiation for so long that it's become something else entirely. Here's the paradigm shift. Scientists have been hoping that interstellar objects like 3I Atlas would give us a window into other stellar systems. But if Majolo is right, what we're looking at isn't a pristine sample from another star system. It's a heavily modified, radiation-processed shell that has been fundamentally changed by its journey through interstellar space. Majolo said that 3I Atlas is now a product of its interstellar journey rather than where it came from, which raises an obvious question. What's underneath that irradiated crust? What's hidden in the core that might still be pristine material from its origin system? And here's something most people don't know. Professor Avi Loeb has formally requested that NASA release all scientific data on 3I Atlas to the public. Why would he do that? What does he think might be in that data that NASA hasn't shared yet? Drop your thoughts in the comments. What do you think is really going on with this object? The behavior of 3I Atlas after perihelion is now the focus of intense scrutiny. Scientists admit they don't know what will happen next. Will the brightness continue to increase? Will it suddenly fade? Lynn and Badams noted that the comet's evolution after perihelion could be just as unusual as the outburst that preceded it, maybe more unusual. At perihelion, 3I Atlas reached a visual magnitude of approximately 9, but it was positioned so close to the sun in our sky that observing it from Earth's surface was nearly impossible. We had to rely on space-based coronagraphs to see what was happening, and what they showed was an object that looked nothing like a typical comet. This elongated glowing form without the expected dust tail. Comets produce dust. It's what makes their tail spectacular. So, where's the dust from 3I Atlas? One possibility is that the composition is fundamentally ice-rich, with very little solid material. But that doesn't fully explain the explosive brightening. Another possibility is that the object's internal structure is unlike anything we've classified before. Webb observed 3I Atlas back in August. The data confirmed this comet is rich in carbon dioxide, unusually rich. But more importantly, Webb's analysis revealed that the outer layers have been fundamentally transformed by cosmic radiation. In interstellar space, there's no heliosphere protection like we have in our solar system. Objects drifting between stars are exposed to the full intensity of cosmic ray bombardment for millions or billions of years. Computer models showed that after approximately 1 billion years of radiation exposure, the transformation is complete. The outer layers become something different. Carbon monoxide converts to carbon dioxide. The crystalline structure changes. Chemical bonds break and reform. The result is a crust extending roughly 50 to 65 feet into the comet's interior, a shell of radiation-processed material that no longer represents the original composition. And here's the unsettling part. We don't know how thick this crust really is. Majolo said scientists need to take these aging processes into account when analyzing 3I Atlas. You can't assume you're looking at a fresh sample from another star system. But he also said 3I Atlas remains very interesting because if we can compare observations from before and after perihelion, when solar erosion might have exposed deeper layers, we might still glimpse the original composition. That's what scientists are waiting for now. Right now, in early November 2025, it's becoming visible again from Earth as it continues its trajectory out of our solar system. This is our window. The trajectory of 3I Atlas is unusual. It's traveling at over 130,000 miles per hour, moving in what observers describe as an unusually flat and straight path. This isn't the chaotic trajectory you'd expect from an object influenced by planetary gravity for billions of years. This trajectory screams, I came from somewhere else, and I'm just passing through. Some estimates suggest 3I Atlas could be 7 to 12 billion years old. That would make it approximately 3 billion years older than our entire solar system. This object existed before our sun ignited, before Earth formed, before any of the planets we know came into being. What has this object seen? What environments has it passed through? We don't know where it formed, what star it orbited, or what happened to that star. What we do know is that right now, 3I Atlas is moving away from our sun, heading back into darkness, and we have a limited window to gather data before it fades from view forever. This is a one-time opportunity. If you're finding this as fascinating as I am, share this video with someone who needs to see it. Professor Loeb has been vocal about the need for transparency when it comes to interstellar objects. He was one of the leading voices calling for serious investigation of Oumuamua. Now, with 3I Atlas, Loeb is calling on NASA to release all scientific data to the broader research community and the public. His argument is straightforward. This is only the third confirmed interstellar visitor we've ever detected. The data collected represents humanity's best chance to understand what interstellar objects are really like. That data shouldn't be siloed, but there's an unspoken question. What exactly is in that data? What has NASA observed that hasn't been publicly discussed? The scientific community is divided on how to interpret 3I Atlas. Some researchers say it's simply a comet with unusual composition, modified by cosmic radiation, but others are less certain. They point to the anomalies, the explosive brightening that doesn't match models, the missing dust tail, the perfectly flat trajectory, and they ask quietly, what else could explain these observations? Here's what makes that question uncomfortable. We have no framework for answering it. Our entire understanding is based on natural formation processes. We see carbon dioxide and water, and we think, comet. But what if the signatures we're trained to interpret have multiple possible explanations? What if some things we're seeing could be consistent with both natural and artificial origins? How would we even know the difference? Our sample size for interstellar objects is exactly 3. Oumuamua, Borisov, and now 3I Atlas. We're drawing conclusions about an entire class of phenomena based on 3 examples. That's preliminary observation at best. Each has presented surprises. Oumuamua accelerated in ways that couldn't be explained by outgassing alone. Borisov was relatively normal, but came from a different stellar environment. And now, 3I Atlas is brightening explosively, losing water at unprecedented rates, challenging our models. Maybe all 3 are just natural objects with unusual properties. That's the simplest explanation, and it's probably correct. But the explosiveness of 3I Atlas's brightening, the timing of it, the way it happened right at perihelion, that keeps nagging at researchers. As the comet moves away from the sun, it will remain observable through November and December. Astronomers are collecting spectroscopic data, measuring brightness, tracking changes. The question everyone wants answered: will the activity decrease now that it's moving away from solar heating, or will something else happen? Lynn and Badham specifically noted that the post-perihelion evolution could be just as unusual as the pre-perihelion outburst. What are they concerned might happen? One possibility is the comet simply fades as expected, normal scenario. Another is that activity continues or increases. If there's volatile material inside that's been exposed, it could continue outgassing even moving away from the sun. But there's a third possibility no one wants to say out loud. What if the behavior changes in a way that can't be explained by solar heating at all? What if there's a pattern suggesting internal processes rather than external heating? Some people have noted that the timing of 3I Atlas's outburst, coinciding almost exactly with perihelion, seems too precise. Natural processes are often messy, with gradual changes rather than sudden transitions. The scientific explanation is threshold effect. As the comet heated up, it reached a critical temperature where sublimation rate suddenly increased. That's plausible. That fits known physics. But there's an alternative interpretation. What if the object was designed to activate at a specific distance from a star? Before you dismiss that as science fiction, consider, we've already sent probes that activate at specific times or under specific conditions. We've built satellites that wake up when they detect solar radiation above certain levels. The concept of a threshold-triggered system is basic engineering. The question is whether there's evidence that 3I Atlas is anything other than natural, and the honest answer is, we don't have enough data yet to rule anything out conclusively. What makes 3I Atlas particularly intriguing is its mass. Early estimates suggest approximately 33 billion tons. That's enormous for a comet. Halley's Comet is estimated at around 22 billion tons. So 3I Atlas is significantly more massive. Combined with the other anomalies, high velocity, explosive outgassing, unusual trajectory, it adds another data point to things that make this object stand out. Think about that journey, 7 to 12 billion years. This object has been traveling since before complex life existed on Earth. It survived encounters with who knows how many stellar systems, gravitational perturbations, radiation from sources we can't identify, and it emerged intact, still coherent, still recognizable as a discrete object. That in itself is remarkable. The irradiated crust Webb detected might be part of the answer. That 50 to 65-foot thick layer could be acting as protective armor, shielding the interior, maintaining structural integrity. It's a shell forged by billions of years of cosmic ray impacts. In a sense, the journey itself made 3I Atlas more durable. But here's where it gets interesting from an engineering perspective. If you were designing a probe to survive interstellar space for billions of years, what would you do? You'd need radiation protection, structural integrity for micrometeorite impacts, a design handling extreme temperature variations, and you'd want it mostly passive, only activating when encountering specific conditions. An irradiated crust would serve many functions: protect the interior, provide structural strength, form naturally by the environment, requiring no active maintenance. And if there was something underneath needing to remain dormant until triggered by proximity to a star, that crust would keep it safe. I'm not saying that's what 3I Atlas is. I'm saying the characteristics we've observed: age, mass, protective crust, threshold-triggered activity, are also consistent with a designed object meant to travel between stars. That doesn't prove anything. It means we should be thorough. This is why the scientific method exists. You gather data, test hypotheses, look for ways to distinguish between competing explanations. Right now, we need more data. If 3I Atlas fades predictably, if behavior matches refined models of irradiated comets, we'll have a natural explanation. But if behavior continues deviating from predictions, if there are patterns not correlating with solar distance, if spectroscopic data reveals compositions challenging our understanding, then we'll need to expand our hypothesis space. That's uncomfortable for scientists because entertaining hypotheses outside conventional frameworks opens you to criticism, accusations of speculation. But that discomfort shouldn't prevent following data wherever it leads. Loeb has argued repeatedly that stigma around discussing non-natural origins is itself unscientific. Science is supposed to be agnostic about outcomes. You propose hypotheses, test them against evidence, follow results. We are living in a moment of cosmic significance. For the first time, we have technology to detect, track, and analyze objects from other stellar systems. James Webb is giving us unprecedented insights. Our network of space-based observatories provides continuous monitoring. This is the golden age of interstellar object research. But it's a brief window. 3I Atlas will be gone within months, disappearing back into emptiness between stars. Each visitor is precious, an opportunity we can't afford to waste. Right now, telescopes around the world are pointed at 3I Atlas. Scientists are analyzing spectra, calculating trajectories, modeling internal structures. The data is accumulating. The picture is becoming clearer. Whatever we discover will change something about how we see the universe. 3I Atlas came from somewhere. It traveled for billions of years to reach us. It survived conditions we can barely imagine. And now, for a brief moment, it's here. Close enough to study. Close enough to learn from. It's behaving in ways we didn't predict, revealing properties that force us to think harder. The question isn't whether 3I Atlas is strange. It clearly is. The question is, what does that strangeness mean? Is it the strangeness of a natural universe more diverse than we've given it credit for? Or something that makes us reconsider fundamental assumptions about our place in the galaxy? Time will tell. The data will tell. This isn't just about one object passing through our solar system. It's about how we approach the unknown, whether we're brave enough to follow evidence wherever it leads, even to uncomfortable places, whether we're willing to ask difficult questions and accept uncertain answers. 3I Atlas is still out there, moving away at over 100,000 miles per hour, carrying its secrets back into darkness. But for now, while it's still visible, we have a chance to learn, to observe, to question, to wonder, and maybe, just maybe, to discover something that changes everything. Drop your thoughts in the comments below. What do you think 3I Atlas really is? If this video opened your mind to new possibilities, share it with someone who's as fascinated by cosmic mysteries as you are. Hit that subscribe button and turn on notifications because we'll be following this story closely as more data comes in. The interstellar visitor has arrived, performed its unexpected display, and is now departing. What it leaves behind is questions, important questions that deserve answers. The universe is speaking to us through these objects. Are we listening carefully enough to hear what it's saying? Thanks for watching, and I'll see you in the next video.